In this video, I'm going to give you a very quick introduction to machine learning using Apache Spark ML. I'm going to use a tool called MiniEnv. This is a tool I built that helps instructors deliver sample applications to students. For students, it's super easy because they just run sample applications in their own environments on the web, so they don't have to install any tools or anything on their machines. Let's go ahead and jump into it. So this is an instance of MiniEnv. MiniEnv runs on Kubernetes. This is running on a single node Kubernetes cluster. Here you can see we have a list of 5 tutorials. Most are around Jupyter notebooks, but I have a couple around RethinkDB as well. So I can go ahead and select the Intro to Spark ML tutorial and click Run. Now what's happening behind the scenes is it's actually creating an environment for me. So any changes that I make in the environment, no one else will see. So you can imagine if you have multiple students who are working on a sample application, they can all run in their own environment. And again, I'm doing all this in the web. I didn't need to download any tools whatsoever. Final note is it's based on Docker Compose. So any sample application that you can set up running Docker Compose can run inside MiniEnv. So while this is starting up, you'll notice there's 2 tabs that showed up. The first is a notebook tab. This is a Jupyter notebook, and this is essentially how I'm going to show you how to do machine learning. So if you're not familiar with Jupyter Notebooks, basically a series of cells. Cells can either be markup, informational, telling the user what's happening in the notebook, for example, or actually code cells that you can execute. You'll also notice an Edit tab popped up. The Edit tab is useful for students to be able to edit source code of a sample application, or in this case, edit the actual data set we're going to use to do our machine learning. So in this case, we have a single file called house prices. So in this demo, we're going to predict the price of a house, a very common machine learning problem. So you can see here we only have 3 data points. You would typically not train a machine learning model with only the 3 data points, but the point of this tutorial is to show you the tools and give you a very quick introduction to how you do it and not try to build an effective machine learning model. But with MiniEnv, one of the things I can do is I can edit this data set. So I can add another house here, and I can save that. And then you'll notice when we go through the notebook, it'll now use that house in building our machine learning model. So another nice thing is you can, if you want to play around with your data, you can go back and forth between the notebook and the Edit tab and change the values of the data to see how it affects your machine learning model. So let's get back into the notebook. So as I mentioned, a notebook is made up of cells, either they're markup or informational or code. All of these are code cells since this is such a simple demonstration. So in this first cell, I'm going to go ahead and execute this first cell. All we're doing is we're importing some Python libraries, and we're getting a reference to our Spark instance. In the next cell, we're going to read in our data. You can see we're reading in this data house prices CSV. That's the same one that I just changed. Now, a CSV doesn't have any type information associated with it, so Spark doesn't know that square feet, bedrooms, and price are integers. So in the next cell, we're just going to tell our data frame essentially that those columns are integer types. And the next cell just shows you what the data frame looks like. So you can see that we have that house price that we added to our data set earlier. And you can also see a data frame is essentially a table or a spreadsheet. It looks like a table or a spreadsheet. Okay, so this is the data we're going to use to build our machine learning model. So in this case, we're building a machine learning model to predict house prices. That's the point of machine learning and machine learning models. You're trying to make predictions. So whether you're predicting the price of the house, or whether you're building a self-driving car and you're predicting whether an object is a stop sign or a person, the whole goal is to make predictions. Now this is what's called a regression problem. A regression problem is when you want to predict a real number like the price. So this is a regression problem, and we are going to use linear regression to build our machine learning model. So in the next cell, we're importing some Spark ML libraries. a pipeline, linear regression, and a vector assembler. And I'll explain what those are in a second. So we're going to basically create a machine learning model with 4 lines of code. All right, this first line of code, we're using what's called a vector assembler to assemble our features. Okay, so features are, there's 2 main concepts that you need to understand when building a machine learning model, a supervised machine learning model, which is what this is. What are your features and what is your label? So the features are the data points that you want to use to predict your outcome. So in this case, we're saying we want to use square feet and bedrooms to predict our price. We don't believe in this particular case that color is going to play a large role, so we're going to exclude that from the list of features. Now, you could use all of your features. I just really wanted to show what it would look like if you wanted to select just a few features, right? So we're going to use square feet and bedrooms. What the vector assembler is going to do, it's going to take those input columns and turn them into a vector when it comes time to build our machine learning model. So this next line where we're creating an instance of linear regression, this is the machine learning algorithm we're going to use to build our model. So there are some parameters here you don't need to worry about just yet, but this is important, which is the label column. This is telling the machine learning model or algorithm what column we want to predict, right? So in this case, we want to predict price. And then, of course, our features column. So our features column is called features because in the line before, we converted square feet and bedrooms to a single vector called features, right? In the next line, we create a pipeline. A pipeline essentially just consists of stages, which are things that are going to be executed when you go build your model. So in this case, we're going to run our assembler, and then we're going to run our machine learning algorithm. And finally, you call fit on your pipeline, and you pass in the data set you want to use to build the model. So in this case, it's called DF, which is our data frame, right up here. And then we create a model. Right? So that's not going to take very long because we only have 4 data points. If we had hundreds of thousands of data points, it would definitely take a lot longer. In the next cell, we're simply creating a function that we can call to make predictions, but you can see how we make predictions. So the way we make predictions is we create a data frame of the data we want to use to make the prediction. For example, I want to predict the value of a house that's 2,400 square feet and has 4 bedrooms. We create a data frame with the names of the feature columns and the values that we want to use in our prediction. Then we call model.transform, the transform function on our machine learning model, and we pass in that data frame, and in response we get a data frame. So now we can just call that function, and like I said, we're just going to predict what is the price of a house that's 2,400 square feet with 4 bedrooms, and then we'll show what the prediction is. So you can see we passed in square feet 2,400, bedrooms 4. It converted it into a vector called features that had just those 2 values. And then we get our prediction, which in this case is $132,557. Probably not a very good prediction, but hopefully you understand the process that we went through in order to get that prediction, and that's all that really counts. Okay, so I wanted to keep this video really short. One other thing I want to mention, this particular tutorial is on my GitHub repository, markwatsonatx/tutorial-spark-ml-intro. And like I said, all of these tutorials are built on top of Docker Compose. So if you want to run this locally, you don't want to have to install Jupyter notebooks or Python or anything like that, you can simply clone this repo and run Docker Compose, and you'll have that sample available to you. All right, that's another. I love using Docker Compose for sample applications. It just makes it so easy. And then finally, I have a blog post where I go over this exact use case. So if you want to check that out, you can go to my Medium blog, which is medium.com/markwatsonatx. Right. Hope this was useful. Please let me know if you have any questions or run into any issues. Thank you.